Hey, what's going on, everybody? It's me, it's the original gamer Stevie Stroh, and we are back for a very long overdue lesson and chapter in programming in BASIC on the color computer. It's been a long time since I've done this. I'm ashamed to admit it. I'm embarrassed. I'm sorry. But I'm back, and I want to try to get this done, man. I want to finish this book because I started this, God, a year ago, longer. And I wanted to get through the book, refamiliarize myself with the basics, share the process with somebody who either is interested in learning it for the first time or just wants to relive the memories of using this ancient programming language. So we're going to do it. I want to thank everybody who has watched these videos. I want to thank everybody who's been asking me to make more and encouraging me to make more because it's happening. And I'm going to start on chapter 10 right now, which is arithmetic, and this is dealing with the Go subroutine. And I could have sworn I did this. I swear to God I did this. Maybe I did, and I just forgot where I put the video, so I'm doing it again. So we're gonna start off on chapter 10. Chapter 10 is called arithmetic, and so here it is. Here's our great book right now. So solving long math problems fast and accurately is a task your computer does with ease. Before typing long, difficult formulas, though, there are some shortcuts you'll want to use. An easy way to handle complicated math formulas is with subroutines. Type in this program. Okay, so it says, I guess I got to click on the right thing here to get my mouse in the right spot. Okay, so 10, print quote, executing the main program, end quote. 20, go sub 500. 30, print quote, now back in the main program. 40, end. Okay, so here's 4 line numbers. So line 10 is going to say print executing the main program. Line 20 says go sub 500, which is down here. Line 30 says now back in the main program. Line 40 says end. But here we have a 500 line that says, well, now I'm executing a subroutine and I'm going to come back. So what do we expect the output of this to be? Let's finish our typing here and find out. So we're going to type in line 500, print quote. I keep forgetting quote's not where it is on my keyboard. Executing the subroutine. Did I spell subroutine right? R-O-U-T-I-N-E. And unfortunately, the Coco did not have spell check. 510, return. And so if you kind of follow the green lines here, 10 is going to print executing main program. 20 is going to go sub and go to a subroutine on line 500. That's going to say executing the subroutine. That will then return, go back to line 30 and say now back in the main program. So when we run this, what is the output going to say? Executing the main program, executing the subroutine, now back in the main program. So it actually output what it did. So what does all that mean? What does GOSUB mean? It's a way to have a chunk of code, a little part of your program that's somewhere else in the program that you might want to call on more than once. And so I think maybe a modern term for this in programming might be called a library, where you create a library or a snippet of code that you're going to use over and over again. So you can create a subroutine that you can call upon with this command called GOSUB or go to subroutine. At the end of the subroutine, you always have to have the statement return to go back to wherever it was called from, and then the program will continue to execute line by line within the program. So we've just kind of learned that little statement and that little process right there. So as we continue to look through the glorious manual here, it says go sub 500 tells your computer to go to the subroutine that starts at line 500. Return tells the computer to return to basic to the basic word that immediately followed go sub. Delete line 40 and see what happens to your program. So if I do a list and I see what my programs are, and I do 40, and I just hit 40 and enter, and now I type in list, and now line 40 is gone. So as I'm stepping through here and reading this, it's going to say executing. It's going to go sub 500, which will say executing subroutine. It'll then say now back to the main program. Then it's going to go to 500 again, executing subroutine. Then it's going to get to the word return, but it's not going to know where to return from. I think that's what's going to happen here. Yeah, RG error. RG means return without GOSUB. You have asked me to return somewhere, but I was never sent to this as a subroutine. So it's basically an orphaned return statement that never had a GOSUB pointing to it. So that is what that error message means right there. And so since we deleted the end line, that's why we got this error. And so this subroutine, now it's saying we can use this subroutine to raise the number of any power. Input, type in a number. All right, so I guess we're going to go ahead and erase this program in memory right now because it just didn't do anything. All right, so we're going to say 10, quote, input. Oops, not quote input, but it's input, quote, type a number, quote, semicolon, n. What does this statement do? The input statement asks the user to type something in. It's waiting for the input from the person running the program. Once that has been input, it will then assign it to a variable. Because I'm using the letter n without anything after the end, this is a numeric variable. If I had a $sign after the end, this would be considered a string variable. So by saying input followed by n, I'm only going to accept numeric variables or numeric inputs. And those numeric inputs will then be stored in a value in memory that is labeled as variable as an n, as a number. And so now line 2, we're going to input, quote, and when you say input and you put a message in quote, it's kind of like doing a print before an input statement. So it's actually printing out a message in the process of inputting these things here. So when I say input, quote, type the power you want it raised to, and we're putting a semicolon after that end quote there to avoid having excess spaces between the statement and the actual input question mark prompt. And then we're going to input that as a variable that's going to be labeled as P for power. So we're going to input a number. We're going to ask somebody to enter a number. We're going to input a power. We're going to then use that variable P to know what power to raise it to. Line 30 says GOSUB 2000. Okay. Line 40 says print colon. Where the heck is the colon? Dash on the keyboard. I think this is why I stopped doing these videos for a while. I actually had a rage quit situation. I couldn't find out where the bloody colon key was on the real PC keyboard. I'm running VCC as an emulator here, and I couldn't find the colon key, and I got really mad. I got really frustrated, and then I was like, screw it. And I think that's why I'm now having the flashback of trying to do this chapter, not finding the gosh darn colon key and just wanting to smash and stop making this video. So there's the colon key. The colon key on your keyboard, on your PC keyboard, is the dash or the minus key. So print colon says print, but we're going to do more. Print n, which is the number that we input, quote, to the power of end quote p. That's not a quote. To the power of number 2, okay, to the power of p, open quote, is close quote, e. Now what is e? E has not been defined yet. E must be the equation. So as I'm stepping through the logic here, we're asking the person to enter a number which will be labeled as variable n. We're asking them to raise a power which is labeled as variable p. We're going to line 2000, which we haven't typed in yet, but when we come back from line 2000, we're printing the answer that's going to say the number you picked to the power of the power you picked is e. So what is e? How do we come up with e? E meaning answer, equation, whatever the thing may be. So when that's done, 50 is going to say go back to 10. And just keep asking these questions over again. So this is the main loop of our program. We're going to ask for a number. We're going to ask for a power. We're going to go to 2000. Some type of magic's going to happen. We're going to come back. We're going to give them the answer. And then we're going to start all over again and ask them to do it again and again and again. So now we are going to get into our subroutine starting on line 2000. And this command here is called rem. Rem means remark. This is like putting comments in your code. So we're going to say this is the formula for raising a number to a power. That's line 2000. On line 2010, we're going to say E equals 1. So we start off by defining v as being 1. Now, we're going to do a for next loop. On line 2020, we're going to say for x equals 1 to p, meaning the power we chose. So if I said raise something to the power of 5, it's going to start at 1, then go to 2, then go to 3, then go to 4, then go to 5. Okay, now 2030, I'm going to say e equals e times n. How do I get to an asterisk now? I got to find out where the asterisk is on my keyboard. There it is. It's shift. The asterisk is shift dash. So what should be the minus key on my keyboard is actually the asterisk. Okay, so e equals e times n. So we start off saying e equals 1. And again, let's say I said take the value of 1 and raise it to the power of 5. The first time it's going to say e equals 1, and this for next loop here is going to say we're going to start at 1 and we're going to do this 5 times, or we're going to do it 1 time. Start over. If I had said take the number 1 and raise it to the power of 5, 1 to the 5th power, it would, for x is from 1 to 1. And during that time, it's going to say e equals e times n. N was the power of 5. And then when it's done, and I say on line 2040, and I say next x, and come back, then it's going to count that many times. In this case here, it only counted 1 time, and so 1 times 5 is 5. So 1 to the 5th power is 5. And then at this point here, on 2050, we have a little kind of fixer-upper here. If p equals 0, meaning I want you to raise something to the power of 0, we're going to say then e equals 1, and then 2060 is going to return. And in case you don't know what that means, what am I saying here? In case you don't remember or whatever, but anything to the power of 0, anything to the 0 power is automatically 1, right? So this is basically saying we're going to try to run this formula, and then when we're done with the formula, depending on what you entered, because if the number was 0, 1, technically this probably would have worked out the same anyways here. I don't know. But we're going to find out here right now. Let's go ahead and look at the code. When I run it, type in a number. Let's just say 2. And what power do you want to raise it to? 2 to the power of 3. 2 to the 10. Did I say 2? I said 2, but I typed in 10 to the power of 3 is 1,000. How do we know that? 10 times 10 is 100 times 10 is 1,000. So when you do that 3 times, that's how you do your exponential stuff. That's your exponents. So 10 to the 1 power is 10. 10 to the 2 power is 10 to the 1 is 10, 10 to the 2 is 100, 10 to the 3 is 1,000. So in decimal system, it just continues to multiply by 10. So that's what we just did right there. So let's try this in binary. Let's take the number 4, and let's do it to the 2nd power. 4 to the 2 is 16. And so in binary, everything is base 2, right? So you start off with 1, 2, 4, 16, and you double as you're going through the numbers. So to the 4th power, 1, 2, 4, 16. If it was decimal, it would be 1, 10, 100, 1,000. You know, and that's how kind of the decimal system works. So 10, 100, 1,000 is how those work. So on and so forth. So that's what this thing is doing. And it's doing it in the form of a subroutine, which is pretty cool. So if I say 10 to the 1 power, 10 to the 1 power is 10. If I say 10 to the 0 power, this is where it goes back, and it used that little fail-safe mechanism on line 2050, where if p equals 0, then e, which is your answer, is going to automatically equal 1, because anything to the power of 0 automatically becomes 1. Pretty cool little program. A pretty cool little situation of watching me struggle with math in my head here out loud, which was kind of cool. And that's the program. Now, do we want to, what's the break key? Is it escape? What is break? Is delete break? I don't know. Control C doesn't work. I forgot how to break out of the VCC. What is break? How do I break? Gosh, it's been so long since I used this. How do I break? End. There we go. End is the break key. Note to self. End is the break key. All right. Do I want to save this little cheesy program? Why the hell not? We're going to save this as chapter 10, page 61. We'll save it out. Let me make sure it's on my virtual disk. All right. So I just saved that little program there. All right. So I'm probably confusing you more than I'm confusing myself. But it says also we've introduced you to the colon in line 40, which is you can combine more than one thing on a statement here. So it says that the colon in line 40, you can combine program lines using the colon to separate them. Line 40 contains two lines, a print statement and a print n to the power of p is e statement. It says the rem statement. The rem in line 200 means nothing to the computer. Put rem lines wherever you want your program to help you remember what the program does. They make no difference in the way the program works. So rem is known as a remark. Now it says here's your do-it-yourself program 10-1. Change the above program so that the computer prints a table of squares, a number to the power of 2 for numbers, say from 2 to 10. I don't even know what the hell you just said, dude. Change the above program so that the computer prints a table of squares, a number to the power of 2 for numbers, say from 2 to 10. Okay, I think it wants us to write a program to print things to the second power. I don't know. That's way too confusing. All right, we're going to skip on that one. All right, give the computer a little help. As math formulas get more complex, your computer needs to help understand them. For example, what if you want the computer to solve this problem? Divide the sum of 13 plus 3 by 8. All right, 13 plus 3 is 16. Divided by 8 is 2. You may want the computer to arrive at the answer this way. 13 plus 3 divided by 8 equals 16 divided by 8 equals 2. But instead, you can give the the computer arrives at another answer. Type this line in and see. Print 13 plus 3. I keep forgetting what keys are. 13. How do I get to plus now on my Coco? Great question. All right, let's look at my real Coco and see where the plus is on the keyboard. On the real Coco, the plus is above the semicolon. Okay, there we go. Print 13 plus 3 divided by 8. All right, and we got 13.375. So what it did is it added 13 plus 3 divided by 8. And so the computer looked at this very literally. I think this is what it's trying to show us right here. We know what we think we wanted. The computer did what it does in a very literal sense. So literally the computer added 13 plus 3 divided by 8. And so like if I even said right now, print 3 divided by 8, that happens to be 0.375. So it added 13 to the 0.375 and it came up with that. So why is it telling us this right now? Here are the rules of arithmetic. The computer solves arithmetic problems in this order. First, it solves any multiplication and division operations. So it does those first. Then it solves addition and subtraction operations. If there is a tie, more than one multiplication, division, or addition, subtraction operation, it solves the operations from left to right. In the problem above, the computer follows its rules. First, it does the division. 3 divided by 8 is 0.375. Then it does the addition. 13 plus 0.375 is that. So for the computer to solve the problem differently, you need to use parentheses to do this. So in this case here, I'd have to say print 13 plus 3. Oops, I got the wrong parentheses. Print 13 plus 3. And my God, the keys are nowhere near where they're supposed to be. Where's my other parentheses? 13 plus 3 divided by 8. Lord help me with this keyboard. So in this case here, 13 plus 3 is 16. And when you divide 16 by 8, you come up with 2. In order to make the computer process this from left to right like we read it as human beings, we had to put parentheses around it. So now it's becoming kind of algebraic here. This is kind of like how you would do algebra. And ironically, when I was trying to learn algebra in like junior high and middle school, it didn't quite make sense until I actually started programming and I started dealing with variables where n equals this and x equals that, and we have parentheses and formulas and stuff. So programming in BASIC really helped me grasp algebra a little better as a young lad. What do you think the computer is going to print? Write down the answers for each of these problems. So in this case here, 10 minus 5 minus 1. So 5 minus 1 is 4. 10 minus 4 is 5 minus 1 is 4. 10 minus 4 is 6 divided by 2. I say it's going to be 6 divided by 2 is 3. But let's see. Let's try that one. Print. Oh crap, I did a shift 0 trying to find the stupid. That's the Coco's glorious lowercase. Okay, so print 10 minus 5 minus 1. Oh God, the brackets are not where they're supposed to be. God dang it. Oh Lord. Where? Okay. I hate this keyboard. Oh my God, this is probably why I haven't done these videos, is because the frickin' PC keyboard translations suck. Print 10 minus, where's my left parenthesis? 10 minus 5, and that's not the minus. Where the hell is my minus now? 5 minus 1, which is 4. And that's my right parenthesis divided by 2. That's 8. Wow. So I'm completely off. I think it does division before subtraction. So in this case here, 5 minus 1 is 4. Divided by 2 is 2. 10 minus 2 is 8. So yeah, it didn't do it the way I thought it was going to do it. So I thought we were going to get a completely different number. In this case, in the second question, print 10 minus 5 minus 1 divided by 2, which would be 0.5. So 10 minus 5 would be 5, minus 0.5 would be 4.5. I'm not exactly sure how that's going to play out, but I know a 0.5 is going to be in there somewhere. So 10 minus 5 minus... Oh, crap, you and your 10 minus 5 minus... I guess I have to put the word print in there too. Okay, 10 minus 5... minus 1 divided by 2. 4.5. Did that come up right? So 1 divided by 2 is a half. So so that's your 0.5. So that got processed first. So then I guess it's going to go from left to right. So 10 minus 5 is 5. Minus 0.5 is 4.5. I think I figured that one out. Now the next one down, that's all in parentheses. 10 minus 5 minus 1, that should literally be 4. Divided by 2 should be 2. Let's see if that works out properly. Print. Left parens. 10 minus 5 minus 1. Right parens divided by 2. That came up with 2. So I'm not sure how it came up with 2, because 10 minus 5 is 5 minus 1 is 4 divided by 2 is 2. That's how it did it. It did it by using proper math. It took me that long to understand that. Okay, very cool. So then we have 10 minus 5 divided by minus 1 divided by 2. So that's going to really be 0.5. 10 minus 5 is 5. It's going to be 4.5. I think that's what that one's going to come out to be. I'm trying to think like a color computer now. Print. I keep forgetting. I need to label my keys. 10 minus 5 minus 1 divided by 2. 4.5. All right, you get the gist here. My head's ready to frickin' explode. Math was never my strong thing, ever. Still isn't. I hate math, ironically. All right, type each of these commands to check. All right, so here we're seeing how the computer does it, right? So If I say, if I have parentheses within parentheses, and now I want to say 10 minus 5 minus 1 divided by 2. So the 5 minus 1 is going to be a 4. 10 minus 4 divided by 2. Oh my God, it's just, holy crap. You know what? I'm done with that. All right. Hopefully you guys understand it, because I don't understand it and I can't explain it to you because I'm freaking mathematically illiterate. All right. What is the rule on parenthesis? The computer solves problems enclosed in parentheses first before solving any others. The computer solves the innermost parentheses first and then works its way out. Okay. Computer math exercise. Insert parentheses in the problem to show how the computer prints 28 as the answer. Oh my God, no, you're killing me. I'm not going to do that. Okay, print 30 minus 9 minus 8 minus 7 minus 6 or whatever, dude. Good for you. I'm not doing that. All right. Saving routines. The program below uses 2 subroutines. So it's for those who save by putting the same amount of money in the bank each month. Do we want to try this little program? And yeah, I think we're done with the chapter, so we'll do this last little program here. And I apologize, it's been a long time since I've done this. Using a real computer keyboard to try to type doesn't map its way out as smoothly, and because I haven't done it so long and I don't use VCC very often, the keyboard is a little bit of a challenge, and so I've been struggling here a little bit, but I'm also too lazy to edit this video, so you're going to see it how it is. Apologies, but that's just it. So here's the program. 10, input, quote, your monthly deposit, end quote, semicolon, D is the variable we're going to capture. All right, 20, input, quote, bank's annual interest rate, end quote, semicolon, I for interest. Okay, 30, I equals I divided by 12 times, where the hell is the asterisk? Let me look on my real Cocoa keyboard. The asterisk is over above the colon, which I think is right there. Okay, times 12. Divided by 12 times 0.01. So we're trying to turn this interest into a percentage. So if I say 5%, okay, and I have a dollar sign there, and there's no backspace. Okay, I equals I divided by 12 times 0.01. So, for example, if I said, what is my interest rate? My interest rate is 4. What's 4 divided by 12? 3 times 0.01. It would be 0.03. Yeah, I don't know. Whatever. I think that's kind of sort of what it's trying to do. It's basically trying to turn it into a percentage for you. As like if I said 3%, it should end up becoming 0.03. or 0.3 or something like that. We'll see what that's like. Okay, line 40. 40, input, quote, and I'll tell you, math is not my strong thing, as you can see me trying to do it in my head and not succeeding very well. Input number of deposits, and that'll be labeled as the letter P for posits. Okay, line 50 is going to GOSUB 1000. Line 60 is going to print, quote, you will have, and then we're going to actually use a dollar sign inside our quotes, end quote, FV, open new quote, in, end quote, P, open quote, months, and then line 70 says end. So we need to figure out what these subroutines are doing to come up with the value of FV. So now we go to 1000, our first subroutine. This is our remark. Compound monthly interest formula. 1010. N equals 1 plus I, which is your interest. Where the heck is my plus? Where was my plus? Where's the plus on the Cocoa? The plus on the Cocoa is by the semicolon. All right, N equals 1 plus I. Okay, so whatever our interest value that got formulated up there, We're going to add 1 to that on line 1020. We're going to GOSUB 2000. Line 1030 is going to say that FV equals D, which was our deposit, times, oh, I can never remember where the freaking colon is. D times, oh Lord, these parenthesis brackets. You're killing me. You're absolutely killing me here. E minus 1. Oh, freaking Lord. Okay. Okay, double left bracket E minus 1 right bracket divided by I for interest right bracket. Okay, did I do this right? Because I'm struggling with this keyboard. FV equals deposit times E minus 1 on inner parentheses. On the outer parentheses, then we divide that by I. If you recall, it says we process internal parentheses and then we process external parentheses. So we're going to take this value of E, subtract 1 from that, and then divide it by the interest. All right, and then in 1040, we're going to say return. In line 2000, we have remark, formula for raising a number to a power. Okay, and we just did this not too long ago. We probably could have kept that code. We could have kept that code. Maybe I should have kept that code. Whatever. I'm talking. Okay, E. Why can I never remember where the equals is? E equals 1, 2020. 4x equals 1 to the power 2030. E equals E times, dude, where is the asterisk? Where is the asterisk? The asterisk is up here. Times N. E equals E times N. 2040. Next, X. 2050. If P equals 0, then E equals 1, 2060, return. Wow, I got a headache going through all that crap. And honestly, I'm not even going to understand if I even know if this thing did its job properly, because math is not my thing. But let's just try this out right now. What is your monthly deposit? I'm going to deposit $100 a month. Okay. What is your bank's annual interest rate? Let's say it has 2% interest. How many deposits will I make? Well, if it's a year, wouldn't it be 12? Okay. You will have $1,211.06 in 12 months. Okay. So there we have that. Is the math right? I don't frickin' know. Was this helpful to anybody on this planet? I hope so, because it confused the heck out of me. The thing that we've hopefully learned by all of this is that subroutines are a way to call other parts of the program. That's the most important part you should take away from this chapter. The crazy math formulas, well, they're important. They are definitely important to understand how to have your computer calculate for you properly. So what you will probably find later on as you're writing programs, if you're not getting things done and you're not getting the output in the variables you expect, you might have to mess around with those parentheses. And the way it works is it does, if you've got a long math formula for your computer to think about, it's going to do addition, it's going to do, take that back, it's going to do your multiplication and division first, and then your addition and subtraction. So it's a really weird process to how it's doing things. So if you want to control that process, you've got to parenthesize your formulas and your math equations to make them be read in the order you need them to be read. And when you have parentheses, it starts in the middle and then it works its way out and works its way out. And so that's kind of the takeaway from there. And here we go. So what did we learn in chapter 10? Well, we learned the GOSUB command to go to a subroutine. We learned how to return from that subroutine. We learned about the left and right parenthesis. We learned about the colon, which is a way to separate statements on the same line number. We learned about the order of operations and how formulas are done, and the remark statement. and my head's ready to explode. So we're going to call this one an episode. We're going to call this one a chapter. I hope you enjoyed it. Make sure you leave a like, comment, and subscribe, and we'll see you on the next one. Bye-bye, everybody.